Today, in the fourth episode of Simplification, we're going to look at subtracting algebraic expressions. But before we do that, I just want to comment on a sound that was towards the end of episode 3, where you could hear some rather loud birds calling. So for all of you who don't live in sub-Saharan Africa, I'd just like to introduce you to the bird that was calling. This is a hardy-dar, which belongs to the ibis family. And when they're in flight, they look incredibly prehistoric, and they make an incredibly loud noise. So often when 3 to 5 of them are in a little flock together, flying over, all calling at the same time, you'll lose the soundtrack on your TV even, because they are so loud. So they were calling in the second half of my last video, and I just thought I would share them with you. Some people dislike them intensely because of the noise that they make. I just find them absolutely fascinating, and they are so much a part of sub-Saharan Africa. Friends of mine who've emigrated to other continents, when they come back to visit, they hear the hardy-dars and they say, "Oh, now I really know that I'm in Africa," because it's a sound that they miss once they're not having it in their everyday lives anymore. So I just wanted to share that with you. But now we're going to carry on with the matter at hand, which is subtracting algebraic expressions. In the first one, we're going to do in a way that we've done before, where we eliminate the brackets and then we start looking for like terms. So let's do that first of all by writing down the first 3 terms, because they're not attached to a bracket. And then especially remember, when there's a minus sign outside a bracket, it's going to affect the signs inside. So negative times positive is negative. Negative times positive is negative. And negative times negative is positive. Right, to tidy it up, we now need to identify the like terms. So we've got q squareds. We've got QR terms, and we've got R squared terms. So adding up the Q squared terms, first of all, we've got 5Q squared minus 6Q squared is negative 1Q squared, which we're simply going to write as negative Q squared. Negative 3QR minus 7QR is negative 10QR. And negative 2r squared plus 4r squared is plus 2r squared. And if we look at our final answer, it contains 2 variables, and the first variable is going in descending powers, and the second variable is going in ascending powers, and that's the typical way to set out a trinomial in 2 variables. Sometimes we ask to use a specific method in an assessment. And so let's also look at the column method, because it's often specifically asked for. Both these methods are mathematically correct, but as I say, if you specifically asked for this, then you need to know how to set it out. So we set it out by writing the first trinomial down exactly as it is. Okay, remember we're subtracting in this video. So I now write down the second trinomial exactly as it appears in the brackets. So be very careful. Here I start off with a 7QR. There's my QR column, so I must make sure that I put it in the correct column. Now I've got Q squared, which is going to come into this column. And R squared is going to go into that column. And remember, the sign in front of a term is the sign that belongs to that term. So make sure you take the sign with it. And now, if I'm subtracting, the first thing I have to do in column method is I have to change all the signs in the bottom expression, which, if you think about it, is exactly what happened over there. All the signs changed. So I first of all change positive into negative, negative into positive, and then it will be like doing an addition sum. You simply do what the sign tells you. So I've got positive 5 minus 6 gives me negative 1 q squared. Negative 3 minus 7 is giving me negative 10 qr. and negative 2 plus 4 is giving me positive 2r squared. And as you can see, that answer is exactly the same as that answer. Both mathematically correct methods. It just depends on what you're being asked to do. Looking at this is a situation that confuses a lot of people a lot of the time, and that's why I want to address it. It's this word from that causes the problem. So if you read this, it's saying subtract this from that. I could just as well read it the other way around, and I could say from this subtract that. Maybe that makes it more understandable. From this subtract that. So whenever the word from is connected to the word subtract, you've got to be very careful, because it's saying from this one, in other words, starting with that one, subtract the other one. And the best way to remember it is look for the word from and write down the expression that comes after the word from, because it's from that one that you're wanting to subtract the other one. So I'm going to be subtracting. I write this one down exactly as it is, and I'm also going to be very careful to make sure like terms are under like terms. So I'm at my n term now. Take the sign with it. It's negative 2n plus p. Now, because I'm subtracting, I have to change all the signs in the bottom expression and then do what the new sign tells me. So positive change to negative, negative to positive, positive to negative, and now I simply do what it says. Negative 6 minus 4 is negative 10m. Positive 8 plus 2 is positive 10n. Negative 7 minus imaginary 1 is negative 8p. And those are all unlike terms, so that is where I'm going to be ending off. So this is episode 4 in this series on simplification. I'd like you to click on the subscribe button so that you don't miss the rest of the series. All of my series on different topics are set out working from the very, very basics in that topic right up into the challenging questions of the same topic. So you can actually teach yourself from the first episode right through to the last episode and pick up all the skills that you need within a given topic. So I hope this has been helpful to you, and I hope to see you in episode 5.